Hello and welcome, everybody. My name is the Shy Hat, and we're here to do a live walkthrough of the TryHackMe Advent of Cyber events. Sorry, the TryHackMe Advent of Cyber 2023 event. Okay, so today is day 17 of the event. It's an event that goes from the 1st of December until the 24th of December, and I'm going to leave a link to the event in the chat for you all to take a look at in case you want to join in. All right, so today we're going to be taking a look at network traffic analysis. All right, so inside of this web page, what we need to do is we need to click on the Start Machine button over here. All right, so we'll click on that. And that's going to create a split view inside of the browser pane. And that's what this is the virtual machine associated with today's task being spun up. We need to sit around and wait for it to initialize, but while we do that, we can take a look at the documentation for today's challenge. We have a lot to work through today. Hopefully, it is not too tedious. We'll try to get through it as soon as we can. Okay, so what do we need to do for today's challenge? We need to start up a VM, and we need to, and there is split screen available for us. All right. So what are today's learning objectives? So today what we're going to do is we're going to gain knowledge of the network traffic data format. We're going to understand the differences between full packet captures and network flows. We're going to learn how to process network flow data. We're going to discover the Silk tool suite, and we're going to gain hands-on experience in network flow analysis with Silk. So we're talking about network traffic data. The network data is everywhere. It is all around us, even now in this very task. All right. Network communication and traffic are the natural behaviors of today's interconnected computing world. These behaviors represent a constant data flow of daily activities, including daily interactions and business transactions. The data flow offers invaluable network management, troubleshooting, incident response, and threat hunting insights. The table below highlights the importance and key benefits of these aspects. All right, so before we move on, we see that our virtual machine for today's task has finished initializing. So what we can do is we can put the virtual machine in its own browser tab by going down to this button right here, View in Full Screen, and we'll click on that. And that's going to open up a new browser tab that is going to have the virtual machine inside of it. And that means we can go back to our original web page, and we can close out this portion of this pane of the web browser window by clicking on this button right here, which is Exit Split View. We click on that, and now we can have a much larger view of the web page, which will make it a lot easier for us to read what's on the page. All right, so what we're looking at the table below highlights the importance and key benefits of each of these aspects. We've got network management, which monitors network performance, identifies bandwidth bottlenecks, and ensures resource allocation and quality of service. We have troubleshooting, which is identifying network issues, okay? Validating configuration implementations and changes, and setting performance baselines. Incident response, which is incident scope, root cause analysis, and assessments of the compliance aspects of incidents in day-to-day operations. And we have threat hunting, proactive analysis for signs of suspicious and malicious patterns, potential threats, anomalies, and IOCs. Also, behavioral analysis is used to detect intrusions and incident threats. Network traffic comes in various data types and formats. Packet capture format, also known as full packet captures, is the first thing that comes to mind. It provides a granular, raw, and comprehensive view of the network traffic. This format provides all possible data represented in packets in a ready-to-investigate format. This approach is also known as deep packet inspection. Therefore, it is an invaluable artifact for network-level operations. However, this intensive resource needs storage, processing, and analysis capacities to provide comprehensive insight into network traffic. In other words, while PCAPs are very useful for detailed analysis, they are not practical for fast analysis situations as they enclose the actual payload. This situation becomes a pain point when large amounts of data need to be analyzed. The data richness and level of detail provided by the PCAP format comes from the payload that it carries. At this point, it will be possible to speed up the process considerably by running the analysis process on a data format that doesn't enclose the payload data. As a result, it will be possible to process more data in a shorter time with fewer resources, leaving more time for analysis and decision making. Network flow data is a lightweight alternative to PCAPs. It is commonly used in NetFlow format, a telemetry protocol developed by Cisco that focuses on the metadata part of the traffic. In other words, it provides only the summary of the traffic. The details appear similarly to how call details appear on your phone bill. Once again, there are no packet content details with this format. This is why storing, processing, and analyzing this data format is easier than it is with PCAPs. It looks like this data format will help the team accomplish the task McSkitty assigned to them. So a closer look at PCAPs and flows. Let's take a closer look at these two formats to see how they differ and understand what to expect from each one. If you're still unfamiliar with the network terminology and the basics of this task, you can always get help from the rooms listed in the Network Fundamentals module. Okay, so in one case, the model is packet capture for PCAPs, and in network flow it is protocol flow records. The depth of information provided in PCAPs is detailed granular data containing the packet details and payload, and in network flow it is summary data and does not contain the packet details and payload. The main purpose of PCAPs is deep packet analytics, and the main purpose of network flow is summary of the traffic flow. The pros of PCAPs is provides high visibility of packet details, and the pros of network flow is provides a high-level summary of the big picture. Encryption is not an obstacle. And the cons of PCAPs are they're hard to process and require time and resources to store and analyze, and encryption is an obstacle within PCAPs. The cons of NetFlow is that it's a summary only, and there's no payload included inside of the network flows. All right, and the available fields for PCAPs are layer headers and payload data, and in network flow it is packet metadata. The table above highlights the conceptual differences between PCAP and network flow at a high level. Now let's go into a more technical comparison of these two formats and understand why McSkitty chose this approach as a quick solution for understanding overall network traffic activities. Elf Forensic McBlue explains the differences in the tables below. Okay, so the key data files of the PCAP format: link layer information, timestamp, packet length, MAC address, IP and port information, TCP/UDP information, application layer protocol details, and packet data and payload. For the key data fields of the network flow format: IP and port information, IP protocol, volume details in byte and packet metrics, TCP flags, time details, sensor info, and application layer protocol information. Forensic McBlue explains that the significant difference between PCAPs and network flows is the packet detail visibility and processing speed. Remember, McSkitty wants the statistics as soon as possible. You'll help the SSOC team work on the network flows. How to collect and process network data. Network data collection and processing typically involves using network monitoring and analysis tools such as Wireshark, T-Shark, and TCP dump to collect information about the traffic on a network and then analyze the data to gain insight, troubleshoot, or conduct blue and purple team operations. Also, product and system-based solutions will help collect network data in a flow format. The specific tools and methods you use will depend on the size and complexity of your network and your objectives. If you would like to learn more about network data capturing and analysis processes, the Wireshark module will help you get started. The SSOC team lets us know that they have some PCAPs and network flow records. The available data needs to be more organized and ready for analysis. Luckily, one of the team members remembered a suggestion from McSkitty. You can collect network flows from endpoints and network devices in the same way you can collect full packet captures. It's also possible to convert PCAPs to network flows if you need a quick look at network statistics on a pre-recorded file. Many open source tools can help you read network flows or convert PCAPs to network flow data, and Silk is one of the most popular choices. Follow-up recommendations and exploration of tools. Let's continue with McSkitty's suggestion. Explore and use Silk to help SSOC in this task. Silk, or the System for Internet Level Knowledge Tool Suite, was developed by the CERT Situational Awareness Group at Carnegie Mellon University's Software Engineering Institute. It contains various tools and binaries that allows users to collect, parse, filter, and analyze network traffic data. In other words, Silk helps analysts gain insight into multiple aspects of network behavior. Silk can process direct flows, PCAP files, and binary flow data. In this task, you will experiment using Silk tools on binary formats to help the SSOC team achieve its goals. ELF-log-mcblue gives us the network flow data in the binary flow format, so we have enough data sources to get to work with. Okay, getting started with the Silk suite. The Silk suite has two parts, the packing system and the analysis suite. The packing system supports the collection of multiple network flow types, IPFix, network flow, NetFlow v9, and network v5, and stores them in binary files. The analysis suite contains the tools necessary to carry out various operations, list, sort, count, and statistics on network flow records. The analysis tool also supports Linux CLI pipes, allowing you to create sophisticated queries. The VM contains a binary flow, suspiciousflows.silk, in the home Ubuntu desktop directory. You can verify this by clicking on the terminal icon on the desktop and executing the following commands. Okay, so what we're going to do is in the virtual machine that we've put into the other tab, we're going to open up a terminal using either this button, or this button, and that's going to open up a command line terminal for us. We're going to expand out the size of the command line terminal so that we can see the terminal contents nice and big. And then we're going to go to the aforementioned directory, which is home/desktop/ Okay, so what is it again? It's suspiciousflows.silk. This is the file that we're going to be working with today. All right. The next step is discovering the details of the pre-installed Silk instance in the VM. Use the commands provided to verify the Silk suite's installation. Use the following command to verify and view the installation details. Okay, so silk _config/v. All right, so we're going to run that. And then we see a bunch of details about this Silk program and the configurations here. Silk mainly works on a data repository, but can also process data sources not in the base data repository. By default, the data repository resides under the var silk data directory, which can be changed by updating Silk's main configuration file. Note that this task's primary focus is using the Silk suite for analysis. Therefore, we will only use the network flows given by the SSOC team. Quick win that will help you answer the questions. You now know what Silk version you're using. So if we take a look here, this is one of the questions that we're going to answer at the end of today's challenge. But we'll go over this a little bit later. Okay, now we're going to talk about flow file properties with Silk Suite, otherwise known as RW file info. One of the top 5 actions in packet flow analysis is overviewing the file info. Silk Suite has such a tool, RW file info, that makes this possible. Now let's start working with the artifacts provided. We'll need to view the details in binary flow files using the command below. Okay, so we use this command with the file name. So let's copy this. And we'll paste it into our terminal window. And we remember that the name of the file we're working with is called suspiciousflows.silk. All right, so we run the command, and we get a little bit of overview information about this file right here. So we've got the version, the format, the byte order, the header length, the version of Silk that it was created with, I assume, the file size, and the number of records. All right. This tool helps you discover the file's high-level details. Now you should see the Silk version, header length, and total number of flow records and file size. Okay, now we know to view the sample size in terms of count records. We're going to need this to answer the questions at the end of the task. So next we're going to talk about reading flow files with RWCut. So RWCut reads binary flow records and prints those selected by the user in text format. It works like a reading and filtering tool. For instance, you can open and print all the records without any filter or parameter shown in the command in the terminal below. So if we just run RWFileCut, copy that, and then suspicious. So if we just run RWCut by itself, we're going to return every single entry. So every single entry inside of the file, which is probably not what we're looking for. Note that this command will print all records in the console and stop the last record line. Investigating all the records at once can be overwhelming, especially when working with large flows. Therefore, you need to manage the RWCut's tool output size using the following command. So RWCut file name and then num rex equals number. Okay, this command limits the output to show only the first 5 record lines and helps with the analysis process. Okay, you can also view the bottom of the list with the tail rec equals number. Okay, so we're going to copy this command right here. We're going to copy the command right here. And then inside of the terminal, we're going to run it. And we see that, so the format is a bit hard to read because we've made our text a little bit bigger. So let's make the text smaller and see if we can get a better. We need to make the text pretty small to have it all come out very neat looking. I'll try to point out the any relevant information while we're running these commands. But sorry that the text has to be so small to look at it in the proper format. Okay, so up to this point, we read flows with RWCut. Now let's discover the filtering options offered by this tool. Recheck the input. It's designed by column categories, meaning that there's a chance to filter some. RWCut has great filtering parameters that will help you do this. At this point, the -- fields parameter will help you extract particular columns from the output and make it easier to read. So, this particular command right here shows the first 5 records, protocol type, source and destination IPs, and source and destination ports. Alright, so let's start running. Let's run this command inside of the terminal. And we see here that we get the first 5. We get the first 5 records with the protocol, source IP, source port, destination IP, and destination port. And we see those details right over here. This view is easier to follow. Note that you can filter other columns using the tags and the filtering parameter. The alternative filtering field options are listed below. Okay, so we can filter by source IP, destination IP, source port, destination port, duration, start time, and end time. One more detail to pay attention to before proceeding. Look again at the RWCut terminal above and check the protocol column. You should have noticed that the numeric values under the protocol section. This column shows the used protocol in decimal format. You'll need to pay attention to this section as Silk highlights protocols in binary format, 6 or 17, not in keywords. I note and also note, for example, TCP and UDP. Below, Forensics McBlue explains the importance of this detail and how to help you with your cyber career. In the forensics aspect of network traffic, every detail is represented by numerical values. To master network traffic and packet analysis, you must have a solid knowledge of protocol numbers, including the decimal and hex representations. Note that the IANA assigns internet protocol numbers. For example, ICMP equals 1, IPv4 equals 4, TCP equals 6, and UDP equals 17. Okay, so to help us answer the questions for later, we now know the date of the 6th record in the given sample. Alright, so next we'll talk about filtering the event of interest with RWFilter. We've covered how to read and filter particular columns with RWCut, but we'll need to implement conditional filters to extract specific records from the flow. RWFilter will help us implement conditional and logical filters to extract records from the event of interest. RWFilter is an essential part of the Silk suite. It comes with multiple filters for each column in the sample that we're working on, and is vital for conducting impactful flow analysis. However, even though RWFilter is essential and powerful, it has a tricky detail. It requires its output to be post-processed. This means that it doesn't display the results in the terminal, and as such, it's most commonly used with RWCut to view the output. View the examples below. So if we use RWFilter with our file that we're working with today, and we put that in the terminal, let me copy that again. Copy that and then paste it in. So RWFilter by itself doesn't output anything over here. The command is missing filtering and passing output options, which is why it didn't provide any result in return. Let's explore the essential filtering options and then pass the results to RWCut to view the output. Remember Forensics McBlue's hints on protocols and decimal representations. Let's start by filtering all UDP records using the protocol filter and output processing options. So we're going to copy this command. So actually, we're not going to copy this command. The command filters all UDP records with RW filter, passes the output to RW cut, and displays the first 5 records with RW cut. Okay, note the pass equals standard out pipe section, so this must be set to process the output with the pipe and RW cut. All right, so we're going to copy this right here, and what this command will do is we'll first run the rfilter command on our file, and the protocol is we're gonna list out protocol 17, and if we remember, protocol 17 is UDP from up here. And then we're going to pass it into standard out so that we can pipe it into RW cut, and we're going to display the fields protocol, source IP, source port, destination IP, destination port, and we're going to limit it to the first 5 fields over here. All right, so if we run this command inside of our terminal, we get results that are very similar to what the example shows. So we can now filter records on the event of interest. The alternative filtering field options are listed below. So we can list the protocols over here. We can filter by protocols, and the possible values are 0 to 255. So that's 8-bit. Okay, so we can filter by ports. So any port, source port, destination port. And the values are all of the port numbers, all the standard networking port numbers. We can filter by IP filters. So any IP address is -- any address. We can sort by the source address or the destination address. And we can also sort by volume filters, the number of packets or the number of bytes. Now you know how to filter and pass the records to post-processing with Unix pipes. We will use the alternative filter options provided in the upcoming steps. This section is a quick onboarding to make you comfortable with RW filter. We still need a big picture summary to decide where to focus with RW filter. So consider this step as preparation for the operation. We have the essential tools we need to zoom in on the event of interest. Let's discover some statistics and help the SSOC team check out what's happening on the network. Okay, so the thing that will help us answer the questions over here is that we now know how to filter the records and how to view the source port number of the 6th UDP record available in the sample provided. Once again, we'll be answering these questions later. So quick statistics, RW stats. Up to this point, we have covered fundamental tools that will help provide some statistics on traffic records. It is now time to speed things up for a quicker and more automated view of the events. Before you start to work with the RW stats, you need to remember how to use the -- fields parameter that we covered in the RW filter section to fire alternative filtering commands for the events of interest. If you need help using these parameters, refer to the RW filter section and practice using the parameters provided. If you're comfortable with the previous tools, let's move on and discover the power of statistics. Okay, so in this particular command right here, count limits the number of records printed to the console, so count 10. Values equals records, packets, bytes, shows the measurements in flows, packets, and bytes. And values equals SIP distinct and DIP distinct shows the number of unique IP addresses that they are going to be used with the filtered field. This command shows the top 5 destination ports, which will help you understand where the outgoing traffic is going. Okay, so we're going to run this command right here inside the terminal. And it provides output much like what is provided in the example over here. We now have better statistics with less effort. Look at the terminal output above. It shows us the top destination ports and the number of IP addresses involved with each port. This can help us discover anomalies and report our findings together with the SSOC team. Remember, flow analysis doesn't focus on the deep details as you work on Wireshark. The aim is to have statistical data to help McSkitty foresee the boundaries of the threat scope. Okay, so to answer the questions for later, you now know how to list statistics and discover the volume on the port numbers. Okay, so now we're going to assemble the toolset and start hunting anomalies. Congratulations, you have all the necessary tools and completed all the necessary preparation steps. Now it's time to use what you've learned and save Christmas. Let's start by listing the top talkers on the network. Okay, so we're going to use this command right here to list out the top 10 IP addresses that sent bytes over the network. Okay, so we're going to run the command, and let's make this a little bit bigger. Let me adjust the size of the window a little bit. Okay. So we see that these are 1, 2, 3, 4, 5, 6. Okay, so these are the source IP addresses that transfer the most data inside of this file here. So check the percentage bytes column. We have revealed the traffic volume distribution and identified the top 3 talkers on the network. Let's list the top communication pairs to get more meaningful and rich statistical data. And we're going to do so with this command right here. So we copy this. And let's clear the terminal so that we can get output that is close to the top of the screen. Okay, so this should be, let's look at the percentage bytes and percentage records columns. These two columns highlight where the majority of the traffic originates. Now the top talkers stand out since they're creating the majority of the noise on the network. Remember what we found in the last part of the RW stats. The high traffic volume is on port 53. Let's focus on the DNS records and figure out who is involved. All right, so we'll run this command right here. And what are we doing? So we're going to filter by any port is 53. So we're filtering by port 53 and passing it by standard out. And then we're going to get the statistics with RW stats. And then we're going to get the source IP, destination IP, and then we're going to get the records, bytes, and packets for those entries, and we're going to limit the count to 10. So let's run the command here. And we see that these two pairs of IP addresses are sending this many records and this many bytes with this many packets. All right then. We filtered all records that use port 53, either as a source or destination port. The output shows that approximately 99 of the DNS traffic occurred between these two IP addresses. That's a lot of DNS traffic, and it's abnormal unless one of these hosts is a DNS server. Even though the traffic volume doesn't represent ordinary traffic, let's view the frequency of the request by using the following command. All right, so we have a command right here. So what we're going to do is we're going to filter all the records by this source IP address right here, with the destination port as 53. Pass it to standard out, and then in RW cut, we're going to list all the field. We're going to list the following fields: source IP, destination IP, start time, and we're going to get the first 10 records. All right, so run that command, and it is, did I Did I copy the correct command? Let's do that one more time. So I'm going to copy that. I didn't copy the command correctly. Okay, so we get the first 10 records of this source address right here, and it all goes to the same destination IP. Okay, so what is the significance of that? So that's a red flag. Over 10 DNS requests in less than a second are anomalous. We should highlight this communication pair in our report. Note that we filtered the second talker that ends with the IP address that ends with 221, as it's the source address of the first communication pair. Let's look at the other IP addresses with the same command. All right, so we're going to run this command right here, and it's going to be looking at the other IP address, and I think it is the same as the other command, only the IP addresses are changed. Okay, and it doesn't seem to output anything. The second command provides 0 results, meaning the second IP address didn't send any packet over the DNS port. Note that we will elaborate on these findings in our detections notes. One final check is left before concluding the DNS analysis and proceeding to the remaining connection pairs. We need to check the host we marked as suspicious to see if other hosts on the network have interacted with it. We're going to use the following command. Okay, so this is going to be getting all of the records with this IP address right here. And then we're going to pass it to standard out. And with RW stats, we're going to get the source IP and destination IPs, and we're going to limit it to the first 10 entries. Let me clear this, and then we'll run the command. Okay, so we see that the first, so we did count 10, but it looks like there were only 1, 2, 3, 4, only 4 entries available for this particular command. So look at the command results. There's one more IP address interaction, which ends with 99, which is this one right here. Let's focus on this new pair by overviewing the communicated ports to identify the services. Okay, so what we're running here is we're running this new command against the IP address that was identified over here, and we're going to get everything that is involved with that IP address, including the source port, source IP, source port, destination port, and destination IP in the protocols. So we're going to copy that and run this against the new IP address, and we see that it only communicates with one other IP address, which is this one right here, using protocol 17, which is UDP. There are 4 records on UDP port 123. We can mark this as normal as there is no high volume data on it. Remember, UDP port 123 is commonly used by the NTP service. From the volume, it looks just as it should. Up to this point, we have revealed a potential C2 over DNS. We can now elaborate on these findings in our detection notes. The communication pair that uses the DNS port is suspicious, and there's a sign that there is a C2 channel using a DNS connection. Elaborated points are listed below. The source IP address, which ends in 221, sent massive DNS requests in short intervals. This pair must be analyzed at the packet level. According to the flows, the destination address has a higher chance of being the DNS server. This means that the source address might be an infected host communicating with the C2. DNSCAT2 is a tool that creates C2 tunnels over DNS packets, so it will be helpful to consider generic patterns created with DNSCAT2 or a similar tool in further analysis and detection phases. Did we find Tracy McCready's C2 channel? Now let's continue the analysis to discover if there are any more anomalies. Remember the quick statistics, RW stats, where we discovered the massive volume on the DNS port? That section also highlighted the volume on port 80. Let's quickly check what is involved with the port 80 traffic. So we can run this command and then copy it. And what is this doing? Okay, so we're filtering against any port, destination, or source with port 80, which is HTTP, and then we're getting all of the source IP, destination port, and we're retrieving the first 10 entries. Okay, we run that. And we see that they're all from the same source IP address. And they're all going to the same destination IP address. We listed the connected pairs that created the noise. Let's reveal the one that created the load by focusing on the destination port. Okay, so we're going to run the same thing again. Not the same thing again. It's going to include the destination port. Wait, how is this different? Let me take a look. So anyways, let me run the command. Okay, so we're going to clear this and then run this. Okay, and this seems to be the same. We have now listed all the addresses that use port 80 and revealed the address ending with 236.223, which was the one created by the one that created the noise by sending requests. Remember, we don't have the payloads to see the request details, but the flow details can give us some insights about the pattern. Let's view the frequency and flags of the request to see if there's any abnormal pattern here. Okay, so we're going to copy this command right here. And what is it going to do? It's going to filter all of the source address as this particular IP address, and it's going to pass the standard out. And then RDBCut is going to return the source IP, destination port, the flags, the start time, and it's going to get the first few entries. Okay, so we see that the flags here are all SYN flags, S. Okay. A series of SYN packets sent in less than a second needs attention and clarification. Let's view all the packets sent by that host first. All right, so we copy this command, and then we're going to get the source IP, the flag, and the destination IP. And then copy, and then paste. Let me do that again. Okay, so we see that to this source IP and this destination IP have all SYN flags, and that is 100% of these records, and that there are this many records. Look at the results. No ACK packet has been sent by that host. This pattern is starting to look suspicious now. Now let's look at the destination's answers. Okay, so we're going to run this. And we're going to see the destination IP address. And then we're going to see what kind of flags that it sends. Okay, so we've got SYN flags, and then we also have acknowledgement flags. The destination address sends SYN ACK packets to complete the three-way handshake process. That's expected. However, we have already revealed that the source address only sends SYN packets. It's supposed to send ACK packets after receiving the SYN ACK responses to complete the three-way handshake process. That's a red flag, and it looks like a DOS attack. We'll elaborate on this on our detection notes, but we still need to check if this host has interacted with other hosts on the network by using the following command. Luckily, there are no further interactions, so we conclude that the analysis and elaborate on the findings on our notes. Okay, so the communication pair that uses port 80 is suspicious, and there's a sign of a DOS attack. Elaboration points are listed below. The source IP address, which ends with 236.223, sent many TCP SYN packets in short intervals. The suspicious address didn't send an ACK request representing the TCP three-way handshake process. There's a high probability of a SYN flood attack. Who is trying to DOS that particular host and why? Is that host compromised, or do we have an insider? All right, so we've reached the end of today's challenge. Okay, so congratulations. You helped the SSOC team identify the network traffic statistics and report the potential anomalies to McSkitty. In this task, we have covered the fundamentals of network traffic data and analysis process. We have also explained the two standard network data formats, PCAPs and network flows, and demonstrated how to analyze network flow using the Silk suite. Now, practice what you have learned by answering the questions below. What version of Silk is installed on the VM? All right, so let's go back to our terminal. And we're going to use some of the CLI commands that we learned in today's challenge to answer these questions. Okay, so the first one, for the first question, the question is, what version of Silk is installed on the VM? Okay, we can use the following command, silkconfig, to get that answer. Okay, so Silk version up here is this. We can copy it, and then we can paste it in as the answer. What is the size of the flows in the count records? All right, so we can use this. We can use this command right here inside the terminal, rw file info on our file, and we -- summary to get those results. And we're looking for the count records. So the count records are over here. We can copy this and provide this as our answer. Okay, the next question is, what is the start time of the sixth record in the file? So we can use this terminal command right here. So rw cut and then we're going to get the field's start time, and we're going to get the first six. We're going to get the first six records, and number 6 is this. The start time is this right here. We can copy that and supply that as the answer. What is the destination port of the 6th UDP record? Okay, so we can use the following terminal command. So we're getting protocol 17, which is UDP, and pass it to standard out using RW filter. And then we're going to cut by the field's destination port and get the first 6 results. And this is the port right here. So copy that and then paste that in as the answer. Okay, so what is the value record percentage of D port 53? We can use this command. So this one is RW stats with the fields D port and the values as records, packets, and bytes. Source port distinct and destination port distinct, and count 10. And we're looking for port 53, which is DNS, and the percentage of records, which is this right here. So we can copy this and provide that as the answer. What is the number of bytes transmitted by the top talkers of the network, by the top talker of the network? Okay, so that is this command right here. So we can get, so we're using RW stats, and we're getting the source IP and the value of bytes and the count of 10 -- top to get the top entries, and it is this IP right here. And are we looking for bytes? Yes. Okay, so we're looking for the bytes, so we can copy this and then paste it in. What is the S time value of the first DNS record going to port 53? Okay, so we're using RW filter, and we're going to use this source address right here, and then port 53, pass it to standard out. And we're looking for the first DNS record. So the first DNS record is first DNS record start time. So that is this one right here. So we copy that, paste it in. Okay, so only a couple more questions to go. What is the IP address of the host that the C2 potentially controls in defang format? Okay, so the IP address that is the potential host for the C2 is okay, so we're going to run this terminal command. and it is it should be this IP address. What you can do is you can copy this IP address and then paste it in. But remember, we need to put square brackets around the dots or the periods to create a defanged format, and then we'll submit that. And what IP address is suspected to be the flood attacker? Okay, so if we go back up here, the flood attacker is this right here. This IP address right here. We copy that. And we're going to paste this in. And then we're going to put the square brackets around the periods. And finally, what is the SYN packets number of records? We're going to run this command right here. And this is a RW filter with this particular source address. And then we're going to get the source IP flag and the destination IP. So these are all the SYN flags, and the number of records is right here. All right, copy that, and then provide that as the answer. Okay, so we've successfully analyzed the network flows to gain quick statistics. If we want to delve deeper into the network packets and network data, you can look at this particular room or module right here. Click completed, and we're finished the challenge. All right, well that was quite the challenge, but we managed to get through it. Now we see the potential for using NetFlow data as opposed to packet captures, and using the Silk Suite CLI program to analyze by a number of different arguments. All right, so we'll be back tomorrow with day 18 of the Advent of Cyber Challenge. This has been the Shy Hat. I hope everybody learned a lot today, and we will see you next time.